Okay, so what we were just doing is called substitution. Right, so that's when you substitute a value in for a variable. Right, and that's exactly what we just did above there. So we were like, okay, what if I work 6 months? I plug it into X. What if I work 12? Plug it into X, and we evaluate our expression. Right, so let's just work with a different expression now. A really simple one, the one I put earlier, X plus 6. So you might have problems that say substitute if X equals 2. Okay, so this time they're giving us the value for X. All I need to do is substitute this. I'm saying, remember the equal sign tells us that they are equal. So now X is 2. X is equal to 2, that just is saying X is 2. So because X is 2, I can just plug it in right there. So then I'm going to get 2 plus 6. See how I just plugged 2 into X? And then I get 8. Okay? Maybe it'll be like the same problem. Maybe it says substitute if this time maybe X equals -3. Okay, so now we're going to take the -3, we're going to substitute it into X, get -3 plus 6, so that should leave you with 3. All right, so going back to that review, adding and subtracting negative numbers, things like that. Okay, so just some substitution examples. You might even have multiple variables. So this is AB, which means A times B. Okay, but a lot of times you'll just see it written like this, and that means you're just multiplying it. Okay, so we have AB, substitute if, this time we have 2 variables, so the only way you can know what this is if you know both the value for A and the value for B. So let's say if A is 1 and B is 2, I'm going to plug it in. So I plug 1 just into A, right? And I plug 2 into B. So then I get 1 times 2, and I get 2. So if A is 1, B is 2, then AB is equal to 2. Or A times B is equal to 2. We'll do X. Okay, so maybe we have something like this. Just one variable. Right, substitute if X equals, let's just pick -3. Okay, so then if you remember, what is 2x? It's 2 times x minus 4, right? And you don't have to rewrite it like that. I like to break it down in as many steps as possible for you all. But you don't have to like write all these steps in your work. Right, and then x is -3. This is where those negatives can get a little tricky, so make sure you pay attention to them. I'm going to plug -3 into x, so it's 2 times -3, right, minus 4. Right, remember PEMDAS. So you do parentheses first, exponents next, multiplication and division. So that means we're going to do the 2 times 3 first, then we minus 4, right? So 2 times -3 is, remember, a positive times a negative gives us a negative. 2 times 3 is 6, right? And then I'm just going to carry this down. So that's annoying. I did that part, now I'm going to do the addition subtraction part. Right, and then -6 minus 4, if it helps, you can always change subtraction to adding the opposite. -6 plus -4. If it, if you like it that way, that's fine. If you like it this way, also fine. You're going to get the same answer no matter what, which is -10. Okay, so if x is -3, then 2x minus 4 is -10. I'm going to do one more example. This time we're saying, just because this one can be tricky. So now we see that there's this negative in front of the x. So we're saying -x plus 3. Okay, so if x is equal to, let's just say 2. Right, so we have that negative. We're plugging the 2 into the x. Right, so -2 plus 3. That gives us 1. Okay, let's do it again. Same problem, but let's see what happens when we have, let's say x is -2 this time. Okay, so this is where it gets a little bit tricky. Remember, this time x is a negative number. We're plugging it in to just the x. Okay, so we still have this negative in front, and then we plug in -2 plus 3. Okay, so this is where I want you to remember that multiplying by -1. So if you remember, I'm going to kind of make a separate space down here. Get this up there. If you remember, like, -1 times a number gives you its opposite, right? -1 times 5 gives you -5. So when you think of this in terms of a variable, -1 times x gives us -x. Okay, that means you can go either way. I can go backwards. I can say -x is equal to -1 times x. That's what we have up here, right? We have -x plus 3. If it helps you, you can think about it in terms of this rule here, -1 times x plus 3. Okay, why am I saying that? Because then you just think, okay, this is -1 times -2 plus 3, right? Or if it helps, we can resubstitute it in here, right? -1 times -2 plus 3, right? Same thing here and here, right? And then we have -1 times -2 gives me +2. 2 plus 3 gives me 5. That's my answer. Sorry, that looks like a negative when I just want it to be like a bullet point. Right, -1 times -2, 2. Right, so this is using that identity property. So this is like the identity property and multiplying by -1 property, right? Just because I want you to remember, when you have like a negative in front of something, it's technically -1 times x, right? So that's why you input your -2 into x, this negative number, and we're saying -2. We're saying the opposite of -2, and the opposite of -2 is +2. Right, so this is where those negatives, again, I always find that students will be really great with like all of this algebra. They're like, oh, this substitution, this makes sense. It's just, I always notice it's the negative numbers that get people stumped the most. And really it's confusing. I make mistakes all the time too. So it's just about double checking your negatives, going over those rules over and over again. And eventually, it'll like become second nature. But yeah, the negative numbers can be really confusing. Okay. All right, so